So in this topic, we'll be studying how to solve the quadratic equations by using the factorization method. So first of all, we should know what is the quadratic equation. Okay, so the general form of the quadratic equation is this: ax squared plus bx plus c, in which the power of x is 2, right? So if you suppress this term, this becomes a linear equation because the maximum power of x is 1, right? So to make it quadratic, the power of x must be 2. Got it? Okay, so where and a, b, and c are the constants or the coefficients of x square, x, and this constant respectively, right? And this is very important. A shouldn't be equal to 0, otherwise this term will be 0, and this whole thing will become a linear equation, right? So this is actually the condition for the quadratic equation. A should not be equal to, a must not be equal to 0. Okay, the next quadratic, what about the quadratic function? If we write this thing and this whole thing is actually the quadratic function, if it doesn't have equal sign with 0, right? So that's why this part is actually called the quadratic function, and it's represented by y is equal to ax squared plus bx plus c. Again, a shouldn't be equal to 0, right? Okay. So the next thing is the methods for solving the quadratic equations. There are a number of methods. The first method is a method of factorization, this one. And the second one is the completing square method. The third one is the quadratic formula, which is actually the actually derived from the completing square method, right? And also you can use the technology like graphing calculators, or even programmable calculator to find the roots of the quadratic equation. Roots mean the values of x, or where the quadratic function or the parabola intersect the x-axis, right? Okay. Now we'll be solving a few questions to understand the method of factorization, right? Okay. I'm going to start with question number 1. It says solve for x and taking part A first. So in A part, we have 4x squared plus 7x equal to 0, right? So here we have actually the general form is this. General form of the quadratic equation will be ax squared plus bx plus c equal to 0. So it means we have only two terms here, this and this. The third term is not present here. So in these type of equations, when we have the two terms, x squared term and the x term, it's easy to find the roots by just taking common in these two terms, and you can see there is x as HCF for the highest common in them, and the leftovers will be 4x plus 7, right, equal to 0. Now according to the null method, that is a into b equal to 0, then a equal to 0 and b equal to 0. So it means if the product of two functions equal to 0, then the first function or the second function must be 0. So the first function here is this. You can see this one is x, and the second one is this one. So we can say that x is equal to 0, and the second function, which is 4x plus 7, should be equal to 0 as well. So from it, we get x equal to 0. And if you shift this 7 to the other side, so it becomes 4x is equal to negative 7, and then divide both sides by 4. So x will be equal to minus 7 over 4. So hence we have found the two values of x. The first one is 0, and the second one is negative 7 over 4. Right? So these are actually roots of the quadratic equation in part A. So all of these parts, B, C, D, E, in E part, you can take a text to the other side, and you'll have the same form that we have dealt with in part A, right? Similar in part F. Now I'm going to solve part G, which is a bit different. It has three terms: the x squared term, the x term, and the constant one, right? Okay, so I'm going to solve the G part. In G part, we have x squared minus 5x plus 6 equal to 0. So in this type of in these type of equations, when we have three terms, how to solve this equation by factorization method. Okay, first of all, you should look for the coefficients of x square and the constant. The coefficient of x square is 1, obviously, and the constant is 6. 1 and 6. Multiply them. 1 times 6, you get 6. Now look for the other combination that gives you 6. Like 2 times 3 is also equal to 6. Any other? No, I guess. So there are only 2 combinations that will give you 6. Now you have to add or subtract the elements of this combination. And if it gives you the middle term, which is -5, right? Okay, another thing you should note that the quadratic equation must be in the descending order. I mean, the first term should be the x squared term, then x term, and then the constant, right? Before doing the factorization. Okay, so 1 times 6 is 6 and 2 times 3 is 6. Now we have to add and subtract, and let's see how to get 5. Okay, if we have 1 times 6 and this second is 2 times 3, what we need, it is 5. So 6 minus 1 is equal to 5. And if you add them, 1 is equal to 7. Okay, subtracted 3 minus 2, it gives you 1. And 3 plus 2 gives you 5. And you can see this combination as well as this combination give you 5. So which should be chosen in these two? Because both are giving 5. So you should look for the signs. It is +1 into +6, which is 6. Now look here, 6 into 1. The signs are +6 and -6. So plus into minus is minus, right? But we need actually +1 into +6 +6, right? What about this one? Both are positive signs. So 3 plus 3 plus 2. So positive into positive gives you +5. Got it? So this should be chosen because the sign we need should be the product of the signs of first and the third term, like plus into plus, plus. Similarly, here plus into plus is plus, but if you choose this one, it is plus into minus is negative, right? So that's why it shouldn't be chosen. So this one should be chosen, x square. Now this -5 as it is. Now 5 will be replaced with this 3 plus 2. And this x should be written as it is, +6 is equal to 0, right? Okay, now you can expand it. X square minus 3 into x is -3x. Similarly, minus into plus minus 2 into x is 2x. +6 is equal to 0. Now we have 4 terms. Basically, we have broken this -5x into 2 terms, -3x, -2x, right? The first term x squared as it is, and the third and the 6 as it is. But this -5x has been broken into 2 terms, -3x, -5x. Now you have to take common in the first 2 terms and then the common in the third and fourth term, right? Okay. So what is the common in the first 2 terms? It is x, obviously, and the leftovers will be x minus 3. This negative sign should be written as it is. Now look for the common in the third and fourth term. It is 2x plus 6, so 2 will be common. And the leftovers will be x. Because of this sign negative, it becomes negative as well, and 3 will be left over. Now you can see that x minus 3 and x minus 3 is the common, right? So I'm taking x minus 3 common. And what will be the leftover? X from the first and -2 from the second. So x minus 2 will be the leftover. Now we'll be using the null property. That is, means if you multiply both, if it is a product and its product is equal to 0, so we can write it as x minus 3 equal to 0. And the second one will be x minus 2 equal to 0. So this shift this -3 there, x will be 3 and x is equal to 2. So we got x is equal to 3 and x is equal to 2. These are the roots of the quadratic equation, right? Okay, now shift to the next question. The other parts like h, I, and j and k are the similar one. Okay. So this is question number 2. It says solve for x, and we have quadratic equations, obviously, ax square plus bx plus c form equal to 0. So I'm going to solve the part B here, right? So in B part, we have 2x square negative 13x negative 7 is equal to 0. So again, you should look for the coefficients of x square and this constant, which is 2 times negative 7, or 2 times 7 is negative 14, or 2 times are 14. So I'm not considering the signs now. So 2 times 7 is 14, right? Any other pairs we have? 1 times 14 is also 14, and no other, I guess. 2 sevens are 14, and 1 times 14 is also 14. Okay, so which gives you 13 if you add or subtract the entries? So if you add these, 2 plus 7 and 2 minus 7, or 7 minus 2. 2 plus 7 gives you 9, and 7 minus 2 gives you 5, but we need actually what? We need 13. Clear? So check the other one, which is 1 plus 14 gives you 15, but if you subtract 1 from 14, it gives you the 13. So this should be chosen, right? Okay, so this 2x square as it is, negative as it is, this 13 will be written as 14 minus 1, and as x as it is, right? Minus 7 is equal to 0. So expanding it, 2x square minus 14x minus into minus plus x minus 7 is equal to 0. So basically we have split it, or we have broken this negative 13x term into these two terms, negative 14x plus x, right? Okay, now taking common in the first two terms and then in the fourth and third term. In the first two term, 2x is the common, obviously, and the leftovers will be x from the first and negative 7 from the second, right? And this plus sign as it is. Now, x minus 7, nothing is common except 1. So 1 should be taken as common. 1 common, leftovers will be x minus 7. X minus 7, x minus 7, same. So this can be taken as common, x minus 7 common, and the leftovers will be this 2x and plus 1. Right? So now we'll be using the null method. Again, I'm showing you this is actually the null factor law, which states that if you multiply two factors and it gives you 0, it means either first one is 0 or the second one is 0, right? So we can state that x minus 7 is equal to 0 and 2x plus 1 is equal to 0. So x will be equal to 7. Similarly, take this 1 to the other side. 2x will be equal to negative 1 and x is equal to minus 1 over 2. So these are the roots of the quadratic equation. Yeah. They're very similar. So I'm taking J part as well. Okay. Okay. In J part, we have 12x square equal to 11x plus 5. Sorry, 15. Yeah. I'm going to make the general form of the quadratic equation, which is ax square plus bx plus c equal to 0. So it means these two terms should be shifted to the other side, right? So we get 12x square minus 11x minus 15 is equal to 0. Now take the coefficients, this one 12 and the constant 15, right? Just multiply them. 12 times 15, it gives you what? 15 to the 30, 3 carry 15 ones are 15. Yes, 180, right? Other factors which will be 1 times 180. There are a lot of factors like these, right? But we need actually 11. So 2 times 90, 3 times. So they're choosing such the bigger ones basically so that we can have the 11. So I'm just a prime factorization, doing the prime factorization with this 180 to get the bigger one. The bigger actually the factors or combination. Anyways, 2 times 90, this will be 3 times 30 and 3 times 10, and this will be 2 times 5, and this will be 5 times 1. So 2 3 are 6, 18, 10, 3 3 are 9, 18, and 10. 6 5s are 30. No. Yeah. This, and this. This gives you 20, and this is 9, right? So we can say that 20 times 9, it also gives you 180. And if you subtract this 9 from 20, 20 minus 9 gives you 11, which is actually the required term, right? Okay, so we'll be choosing 20 minus 9 here. So 12x squared as it is, and this 11 will be replaced with 20 minus 9, right? And this x as it is, minus 15 is equal to 0. Now expanding it, 12x squared minus 20x plus 9x. Sorry, it was 20x. Minus into minus plus 9x minus 15 is equal to 0, right? Okay, taking in the first common the first two terms, 12x squared and minus 20x. So obviously 4x will be common. The highest common factor should be chosen, right? Taken as common. So left order will be 3x minus 5. Similarly, here we have 3 common, right? And the left order will be 3x minus 5 is equal to 0. 3x minus 5, 3x minus this expression is common. So 3x minus 5 taken as common, and the left will be 4x and plus 3. So null factor law, according to null factors law, it will be 3x minus 5 equal to 0 or 4x plus 3 equal to 0, right? So taking this negative 5 to the other side becomes positive 5, and x will be equal to 5 divided by 3. Similarly, here 4x will be equal to negative 3, and x is equal to negative 3 over 4. So these are the required roots of the quadratic equation given. So all of the parts are very similar to these two questions. So you can do them by own. Okay, in the next question we have again the quadratic equations, but we have to simplify these quadratic equations to make them like the general form of the quadratic equation, which is ax squared plus bx plus c. And then we'll be using the factorization method. Like in the question, like in the part A, in A part we have x plus 1 whole square is equal to 2x squared minus 5x plus 11. Okay, so we'll be doing expansion of this x plus 1 whole square. And we can do the algebraic identity, which is a plus b whole square here, right? A plus b whole square is equal to a square plus 2ab plus b square. So this identity can be used to expand this x plus 1 whole square, or even you can do this x plus 1 times x plus 1. So both methods can be followed to expand this. So anyways, I'm using this identity here, which states that the first term square plus 2ab means the first into second plus second term square. So first term square plus 2 into first into second plus second term square, right? Okay, now you can fill it. It is x, first term x, 1 and 1, right? And on the other side of the equation, it is 2x squared negative 5x plus 11 as it is, right? So it will be x square plus 2x into 1 is 2x. 1 square is also 1. 2x square minus 5x plus 11. Shifting these three terms to the other side. So here we are left only 0. And on the right hand side, 2x square, this x square will be negative x square. Negative 5x, this plus 2x will be negative 2x. And plus 11, this 1 will be negative 1, right? And after switching the sides, we get x square minus 7x. 11 minus 1 is 10 equal to 0. So this is actually the general form of the quadratic equation we got. Now we can use the factorization method here, right? So what are the coefficients we have? The coefficient of x squared is 1 and this constant is 10. So now multiply 1 by 10. So we get 10. Other factor will be 2 times 5 is also 10. We need 7. So obviously it should be 2 plus 5. 2 plus 5 gives you 7. So that's why this combination should be taken, right? Okay, so x square as it is. This 7 will be replaced with 2 plus 7, 2 plus 5. And x as it is plus 10 equal to 0. Open the bracket, minus 2x minus 5x plus 10, right? Now taking common in the first two term, x will be common and x minus 2 will be the leftover. Similarly, this negative sign as it is and common in the first, third and fourth term. It is obviously 5 and x minus 2 will be the leftovers. This positive sign becomes negative like this. So anyways, x minus 2 common and x minus 5 leftovers, it is equal to 0. So null factor law states this x minus 2 equal to 0 or x minus 5 equal to 0. So from this we get x is equal to 2 and the second one will be x is equal to 5, right? So that's how we can simplify the quadratic equation first to make this form and then use the quadratic equation, the factorization method to solve the quadratic equation and get the roots, right? Okay, now I'm going to solve this one, E part. In E part, I have 2x minus 1 over x equal to negative 1. So it's very easy. The best method is to make a single fraction on either side. Here we have this fraction. So if I take this 2x to the other side, it becomes negative 1 over x is equal to minus 2x minus 1. Now we have single fraction on either side. If you consider 1 as a denominator of this expression, right? Now you can do the cross multiplication. Like 1 will be multiplied with negative 1. And this x will multiply this whole thing. Minus 2x minus 1. So we get minus 1 is equal to minus 2x square minus x. Now shifting these two terms to the other side becomes 2x square plus x minus 1 is equal to 0, which is obviously the general form of the quadratic equation, right? Now, just taking the coefficients, right? 2 and 1. So 2 times 1 is equal to 2. So we can take only this one. 2 minus 1 is also 1. So because we need the middle term, which is 1. So 2x square as it is, this actually 1. This is actually 1, right? So 1 will replace with 2 minus 1. X as it is minus 1 equal to 0, right? So open it, 2x square plus 2x minus x minus 1 is equal to 0. And 2x common, x plus 1 leftovers. Similarly, 1 is common in the third and fourth term, x plus 1 leftovers. X plus 1 common in them and 2x minus 1 leftovers. So x plus 1 is equal to 0 or 2x minus 1 is equal to 0. X equal to -1 and this will be 2x equal to 1 or x is equal to 1 over 2. So these are the roots of the quadratic equation given, right? In F part, you can do again the cross multiplication. This x will multiply this whole expression. Similarly, this 1 minus will multiply by -9. And you obviously eventually achieve the this form ax squared plus bx plus c. And then you can use the quadratic factorization method to solve that, right? So all of these parts are very similar. You have to solve each part and make this form, and then you can use the factorization method to find the roots of the quadratic equation. Got it? How you understand the topic? Take care. Allah Hafiz.